Sometimes you gotta go. All right, so rational equations and inequalities, and you can't see that because it's not plugged in. And oh, it's up there. Good deal. All right, so rational equations and inequalities. We're going to solve some equations here. So going to kind of come down to all of the same things that it took to add and subtract rational expressions. It's what it's going to take to solve them. Okay, so big things, least common denominator, and then we want to talk about restrictions. And restrictions, another word for that is domain. All right, so it's the same idea for domain as it is for restrictions on X to solve, okay? So least common denominator, what we got to look at is look at each piece and say, okay, what do they have? What do they need? Okay. The first fraction, what's the denominator? Does anybody else have a 2? Nope. So a 2 has got to be part of the least common denominator. The second fraction has what as a denominator? Nobody else has that. The third piece, the equals x, technically that's x over 1, but it needs, it's a 1, really doesn't change anything, right? So if we multiply it by 1, it's not going to change what the least common denominator is. So our denominator is 2 times x plus 1. What we need to do is just get everybody to have the same denominator, okay? So what does the first fraction need? It needs an x plus 1. So the top and the bottom get multiplied by the x plus 1. What does the second fraction need? A 2. So everybody on top and bottom gets multiplied by 2. The third fraction, however, needs what? Both of them. It needs a 2 and an x plus 1. We need to multiply 2 and x plus 1. Okay, so I'm going to multiply out the numerators. The denominators don't matter. Okay, so the top part, we got 2x. I'm gonna write it out kind of separate here. So this is the part we're worried about. We don't even worry about the denominators anymore because we've got them all the same. They all have the same pieces. So now we just need to work out this part. So that'd be 2x squared plus 2x minus 3x would be minus 1x minus 3 plus 10x is equal to 2x squared plus 2x. Okay, and then we try to simplify as much as we can. So the left side, I got 2x squared minus x and plus 10x would be plus 9x minus 3. And on this side, we've got the 2x squared plus 2x. The next thing to do is look at solving that equation. What's in green there? Okay, so if it's got an exponent, then we need to get it equal to what? 0. That's our best bet. Yeah, move one side over or the other. It doesn't matter. I'm going to move this side that's only got 2 pieces over there to the side that's got 3 pieces. All right. Yeah. So I'm just moving both of those pieces. These cancel. Just so happens that these cancel as well. And so that's where he's getting the 7x minus 3 is equal to 0. And now all we got to do is get x by itself. Yeah. X equals 3 over 7. Now, we hadn't done anything with this restriction stuff over here. The restrictions come from setting your least common denominator equal to 0. So we'll divide by 2. X plus 1 equals 0. X can't be negative 1. That's our restriction. Where that comes into play is when you check your answers. X equals 3/7. It doesn't match the restriction, so that's okay. If it did match the restriction, we'd have to throw it away. The actual answer, because there are some, and we'll see one here in a little bit, where the restrictions and the answers we get match, then we got to throw those away. So the ones that match, they cancel each other out. It's basically what happens with that. But this one, we get X equals 3/7. That's the solution that works for this problem. Okay. Biggest things you got to get is least common denominator, and then solve it. Once you get the common denominator, fix all your fractions, and then just like if you were adding or subtracting them, and then solve that equation. So let's look at another one. Example B. So we have x over x minus 5 plus 5 equals 5 over x minus 5. So what's the shared piece? X minus 5. So we know that that's in the common denominator. What's the denominator of the 5? A 1. So is it going to change my least common denominator? No. So least common denominator is just x minus 5. All right. So what does the first one need anything? It's already got it, right? Middle one does need something. It needs x minus 5. So we multiply top and bottom by x minus 5. The third fraction, what it's equal to, does it need anything? No. So we leave it alone. Okay. Now, the numerators are the only parts we care about now. X plus 5 times x minus 5 is equal to 5. That's x plus 5x minus 25. That'd be 6x minus 25 is equal to 5. Do I need to get this one equal to 0? I don't have to. I could, but I don't have to because it doesn't have a degree higher than 1. Anytime it has an exponent on the x, then I have to get it equal to 0 to solve it. Here, we didn't have an x squared or an x cubed or anything like that we have to work with. So we can just get this one to get x by itself. I'm going to add 25. Oh, yeah, that definitely be something I remember. If it's got an exponent, then you need to get it equal to 0. If it doesn't have an exponent, you don't have to. And then just divide by 6. X equals 5. Now, what's the other part that we have to think about? Restrictions. How do we find restrictions? Set the common denominator equal to 0. So we set x minus 5 equal to 0, and we get x can't be 5. But what did we get for an answer? So those cancel each other out, so there's no solution. Because that's the only one we had. The numerator, yes. The numerators are what you're working with. That's right. Okay. Next problem. A little bit more complicated. Got more stuff in the denominators. That's what we want to kind of build up to here. But the same idea as adding and subtracting. So we look at that. We see the first fraction has an x minus 3. The second fraction has an x. The third fraction has x squared minus 3x. That should trigger in our brain. We see an x squared in the denominator minus or plus something to try to factor that. What does that factor as? No. How do I factor that? What's the first thing I always look for? And if I'm factoring, the first thing I always look for is the greatest common factor. What do those two have in common? X. So that leaves an x minus 3 in parentheses. Oh, that's handy, because look at the other two fractions. What's on the bottom of those? So that means my least common denominator is x minus 3. So what does the first fraction need? It's an x. I factored that. And looking at the original problem of what's written in black, what does each one have? The first one has an x minus 3. The third one had an x minus 3. The second one had an x. The third one had a plain x. Yes. Okay. Yeah. All right. So what does the second fraction need? It needs an x minus 3 to make it match up. The third one doesn't need anything because it already had the x and it already had the x minus 3. So we don't have to do anything to him. All right. So top part's all we care about. X squared minus 5x. X minus 3 is equal to 7. Do I have to get this one equal to 0? Yes. Why? Because it's got an x squared in it. I got to get it equal to 0. So that means I just need to move the 7 over here and combine like terms. So that's going to be x squared minus 4x minus 10. Is that right? Make sure I'm doing my numbers right. That is a negative 7. It was a negative 7 to begin with, wasn't it? So that makes it a plus 7, which makes that work out better. Because now that is plus 4. Equal to 0 now. Now I got a quadratic equation equal to 0. I can factor that maybe. Multiply to be 4, add to be negative 4. Negative 2 and negative 2. Just happens to be the same one twice. So x equals positive 2 is my only solution. I need to check that against what? The restrictions. So how do I find it? Set equal to what? 0. X times x minus 3 equals 0. So x equals 0. So x can't be 0 and x can't be 3. Do they match up with what I found as the real answer? No. So this is okay. It checks. Set x equal to 0. And then set x minus 3 equals. Set each factor equal to 0. Well, it's both. Individually and as a whole. So far, so good. Let's get another one. X over x plus 5 and 5 over x minus 5, and then 50 over x squared minus 25. What should I think about doing? Okay, so what does it factor as? Yep. That's nice. It's like you meant for that to happen. So what's our common denominator? Yeah, x plus 5, x minus 5. So what does the first one need? He needs x minus 5. Second one needs x plus 5. Third one needs what's the third one need? Nothing. It's already got both of them. We have x squared plus 5x or minus 5x plus 5x plus 25 equals 50. Simplify. These cancel each other out. Do I need to get this one equal to 0? Yeah, it's got x squared in it. Is it equal to 0? Got x squared minus 25 plus 5x minus 5. Uh-oh. Those are my solutions. But what are my restrictions? Yeah, you set the common denominator equal to 0. And so, yeah, so both of them got canceled out. No solution. Okay? That's the name of the game. Let's look at inequalities. Similar game, but one very important rule that's different. In inequalities, you need to get a 0 on one side because that makes it easy to compare. Because if we're looking at an inequality and we're saying is x greater than 0 or x less than 0, that's much easier to compare than comparing x and x plus 2, which one's bigger than the other one. It depends on how much x is. If x is 0, then one side's bigger than the other. If x is positive 5, it changes. So getting it equal to 0 or getting a 0 on one side at the beginning is what you want to do with inequalities. Not with equations. We don't need to. It's easier with equations. Inequalities, get a 0 on one side first. Okay, so for this one, I would subtract 4. That's the first thing that I would do. So I'd have 6 over x minus 3 minus 4 is greater than or equal to 0. Okay. Then you want to get your least common denominator. What the 4 is 4 over 1. So their least common denominator is x minus 3. Let's go ahead and get our restriction because we know we're going to do it anyway. So x minus 3 equal to 0. X can't be 3. Now, let's solve that inequality over here. What does the first fraction need? Nothing. What does the second one need? Got to be careful here because we got a minus in front of that 4. So it's like a negative 4. So this is 6 minus 4 times x minus 3. Yeah, 6 minus 4x plus 12 is greater than or equal to 0. So we're dropping. It's just like once we get here, it's a lot like the inequalities. You drop the denominators and just look at the numerators. And we're going to solve this inequality. So that'd be, if I put the like terms together, I got negative 4x plus 18 is greater than or equal to 0. And then I'm going to get x by itself. So minus 18. Negative 4x is greater than or equal to negative 18. And then I want to divide by negative 4. What happens when you divide by a negative with inequalities? Flip the symbol. So it makes it a less than. And then 18 over 4 reduces to 9 over 2. Now, this is where it changes a little bit. This is where you got to be, pay pretty close attention. What we've got to do is set up some test intervals here. So the test intervals are going to come from your restrictions and what you found with the inequality that you solved. Okay, so 9/2 is 4.5, right? And our restriction we found was a 3. So our restriction is at, we got this 3, and then we got from 3 to 9/2. The 3 is open circle. The 9/2 is closed circle. Why? Why is the 9/2 closed circle? The equal to mark on it, right? 3 is an open circle because it's restricted, right? It can't be an answer. So that's why it's always, the restriction's always open circle. So we've got 3 intervals that we've got to check some numbers in. So we need to pick a number that's to the left of 3 and plug it into the problem. 0 is an easy number to plug in, right? So we're going to plug that in to the original equation. Okay? So test x equals 0. So the original equation, or original inequality, had 6 over 0 minus 3 is greater than or equal to 4. We got to decide if that's true or false. So 6 over -3 is -2. Is -2 greater than or equal to 4? Yeah, that's false. So that means that area is not an answer. Okay, so this is a false area. Then we need to test something in between 3 and 9/2. What's an easy number that's between 3 and 4.5? 2's not between those. 4 would be. So we're going to test x equals 4. 6 over 4 minus 3. Is it greater than or equal to 4? So no, because that ends up being 6. No, 6 isn't greater than 4. It's true. This area is true. Okay. Then we need to test the last area. Something bigger than 4.5. 5. 5 is bigger than 4.5, so I'm gonna pick it. Test x equals 5. 6 over 5 minus 3. Is it greater than or equal to 4? That'd be 6 over 2, which is 3. So that's false. Final answer. You look at your intervals here. The true part is the part that's the answer. So the true part starts here at 3 and goes up to 9/2, including 9/2. So in interval notation, that would be parentheses 3 to 9/2 bracket. That's our solution set.
So as long as you have a true,
You're going, and it's possible that you have more than one region that's true. Then you would combine those regions.
so how do you know? How do you know which one's to test again?
Your spots on the number line come from your restrictions and solutions. So the only restriction we had for this one was 3, and the only solution we had was 9/2. So those are the places that you're going to put. You're always going to test not the number that is on that spot, but to the left of it, to the right of it, in each place. So we're picking a number that's less than 3 to go to the left of it. We're picking a number that's between 3 and 9/2 to go inside of here. We're picking a number that's bigger than 9/2 to go here. Okay, that's how you're going to always pick those numbers. Let's look at this one. So it's something with a 4 in it as well, but it's a little different here because we got a different denominator. Makes it more fun. Okay, so what are we getting at? What are we getting on one side? we need a 0 over there, so we need to move the 4 to get that. That's what Patricia was trying to say there. I know it's 10 after 9. We're all tired. Less than 0. Okay. Least common denominator. Yeah. They're not going to be too rough on you with these inequalities. It's just not going to be that difficult. All right, and then restriction. Oh, can't see yellow. Sorry. Forgot that one didn't show up. 2x minus 3 equal to 0. 3 over 2. X can't be 3 over 2. That's our restriction. So now we just need to solve this so we can find the other spot or spots that end up on the number line to check with. Okay. So what needs what? Yeah. So that's 3x plus 1 minus 4 parentheses 2x minus 3. And is less than 0. Sorry. And then solve that. So that'd be negative 5x plus 13 is less than 0. Strictly less than here, no equal to on this one. Get x by itself. Negative 5x is less than negative 13. Divide. This is greater than 13 over 5. So I'm going to set up my number line. And I've got two things that go on it for this one. I've got the restriction, which was what? 3 over 2, 1.5. 13 over 5 is 2 3/5, right? So 1.5 goes here, so that's 3 over 2. And then 13 over 5 goes over here. What is it, filled in or open circles? Both of them? I know it's open on the 3 over 2 because it's a restriction. Restrictions will always be open. Very good. Because that's not equal to, it's open on the 13 over 5 as well. So now we got to do some tests. So we need a number that's less than 3 over 2. 0 is always a good one to plug in. And we're going back to the original test, x equals 0. So 3 times 0 plus 1, 2 times 0 plus 1. Is it less than 4? That's what we're asking. 1 over 1 is 1 less than 4. So this area is true. Okay? We pick a number in between 1.5 and 2 3/5. 2 would be a good number that's in between there. So we're going to test x equals 2. 3 times 2 plus 1 over 2 times 2 plus 1. Is it less than 4? So that's 6, 7 over 5. Is that true? Did I that's not a plus 1. I'm not even going to the original problem, am I? No wonder. That's a minus 3. Let's go back. That's still 1 or 1. That's a negative 1/3. That's still true. So I didn't screw up too badly. I knew the middle part shouldn't have been right on this one. So I get 6, 7 over negative 1. Is that right? 7 over, not negative, over positive 1. 7 over positive 1. So that'd be false. So this area is false. And then we need to pick a number over here on this side to see if it might be true or false. Okay, so I'm going to pick a test point there that's bigger than 2 3/5. 3 is a good number. Test x equals 3. 3 times 3 plus 1 over 2 times 3 minus 3. Is it less than 4? That'd be 10 over 3. Is that less than 4? 10 over 3 would be 3 1/3. But yeah, well, depends on what your definition of barely is. So we got 2 areas that are true here, not just one. So our solution would be from negative infinity to 3 over 2 union 13 over 5 to positive infinity. Or x such that x is less than 3 over 2 or x is greater than 13 over 5. That's the set notation for that. I like the interval notation better, which is the way that we'll probably do things for the most part in here. So we're setting up those intervals. Where do those intervals come from again? What are the numbers that are on the bars of the intervals come from? Restrictions and solution to the inequality. That's where those numbers are going to come from. And then you're picking points that are in between them, picking numbers that are in between to test, to decide true or false. Okay? It's true, it's part of the answer. If it's false, it's not part of the answer. Okay? All right. Suggested problems for this week, page 133, 1 through 26, page 147, 69 through 92. This is 1.6, this is 1.7. I don't have your Canvas quiz out there yet. It will be up tomorrow. I'll get it fixed in either tonight or in the morning. So it'll be up there. I did open up the last week's Canvas quiz for you to take again if you want to improve your score. If you're good with what you got, you don't have to take it again. It'll keep the highest. Still keeping the highest. Okay, so you get another shot at last week's Canvas quiz, but you're also going to have this week's Canvas quiz to do, which covers 1.6 and 1.7. So be mindful of that. And next week is exam. We'll